Hey guys, I want to go ahead and do another video. Now we're moving into particle motion. So these couple of videos, I'll be working on particle motion. If you need more, then let me know. We'll do 2 today, okay guys? So these are particle motion. So it says a particle moves along the x-axis, along a straight line. The velocity of the particle is given by this function. The position of the particle, s of t, and we know that s of 0, the initial condition, starts at 10. Okay, cool. Now remember the first part, A and B, A is relatively the easiest part, A and B, okay? So think about that. Find all the values of t, the time, between 2 and 4, for which the speed of the particle is 2. So speed, okay? That's interesting because you have 2 things, okay? You have velocity with respect to time, okay? And then you have speed, okay? You have speed, and that's the difference. Velocity, okay, I would say speed, you're driving a car 30 miles an hour, okay? Velocity is saying you're driving 30 miles an hour due east, okay? So velocity is directional, it's a vector. Speed is just a what we call a scalar, okay? It just tells you how fast you're going. Now speed, okay, speed is the absolute value of velocity, okay? Speed is the absolute value of velocity, so you got to understand that. And this comes up over and over again. Okay, so find all values of t on the interval for which the speed of the particle is 2. Okay, so we know speed is the absolute value of velocity. Speed is 2. So we're going to do the velocity, absolute value of v of t, set it equal to 2. Okay. So what do? I have to solve this. Okay, so I'm going to set this guy. You're going to have to put him in your calculator, set it equal to 2, and solve for t. And that's it, guys. And that's all you would do with the calculator problem. Okay. Now on this year's AP exam, this says calculator is allowed. Now that kind of like a trick question, because if a calculator is allowed, that means it's really not going to help you much with the calculus. Okay. So you might get something like this, but get ready, because remember, you usually get a calculator portion and a non-calculator portion. So you will have to know how to do your integrals, your antiderivatives, basic calculus. Okay, so this is the first part, and if you do that right, you should get t is equal to 3.128. Okay, and then make sure when you plug this into your calculator, you put the absolute value, set it equal to 2. Okay, and then you should be able to get the values. All right, so t is equal to 3.128, and the other one is 3.473. Okay, and that's seconds. Okay, and that's it. That's part A. A little bit tricky, kind of, but you really got to understand what speed is. Okay, part B. Okay, we'll do part B over here. It says write an expression involving an integral that gives the position. Okay. Use this expression to find the position of the particle at t equals 5. Okay, so let's think about this. They want position. Okay, what do they give me? Velocity. Well, how do I get velocity? How do I get position from velocity? Well, you should know this, and I think you guys do. You integrate, you go backwards, you integrate velocity. That's what you do. When you integrate velocity, you're going to get position. Okay, and if you don't know, just kind of write it down. All right. Right, you start off with position, all right, and then you get velocity, and then you get acceleration. Okay, so the derivative of position is velocity. The derivative of velocity is acceleration. Okay, and then going backwards too. If you integrate acceleration, you get velocity. If you integrate velocity, you get position. All right. So just make a note of that. So now where are we going from? We're going from where? They want at t equals 5. All right, well, where do we start? 0. So we're going from 0 to 5. Okay, and that's essentially what I want to do. Okay. Now, that's what they're telling me. Now, there's a couple of things here. It says write an expression involving integral that gives the position s of t. So I'm going to go ahead and write a generic formula, okay, because I might need it later on. Okay. And then it says use this to find the time at t equals 5. So to find the expression, okay, we're going to go from 0 to t because that's just our general rule, okay, vt dt. Now when I integrate that, I'm going to get s of t minus s of 0, okay, and I'll use equals here. So s of t, I'm going to rewrite this, s of t. This negative s of o is going to go to the left, so it becomes a, so this guy is going to go over here, it becomes a positive. S of 0, that's already a positive integral from 0 to t of vt dt. Okay, that's your general expression. Now I have to use it to find what? T equals 5. Okay, so now here it is 5. All right, and s of 0 plus the integral from 0 to 5 of vt dt. Okay, and then you already know that the initial condition, the position at 0, is 10. So you have 10 plus the integral from 0 to 5 of vt dt. And that'll give you the position at t equals 5. Now you notice, all you have to do is write vt dt. You don't have to write this whole expression, because they already tell you v of t is equal to this. So you're set. Just write v of t, okay? And that's it. Plug that into your calculator. Hopefully everything goes well. Okay, and you should get negative 9.207. And you know what? This guy here, I keep forgetting to do that. Make it an x, because when we integrate with respect to t, we're going to substitute it. So this will be v of x right here. Okay, v of x. Alright, and you should get the position is negative 9.207. Okay, so the position at t equals 5 is actually going to be to the left. Okay, alright, part C. And if you do those two, you get 4 points. 4 points out of 9 already. And you're in a good position. Alright, part C. It says find all the times t on the interval from 0 to 5 at which the particle changes direction. Justify your answer. So now we're getting to the bit more difficult parts. But think about this. You're driving a car. Imagine you're driving a car. How do you change directions? Well, let's say you want to make a U-turn, right? Because this is particle motion. Particle motion, right? You're driving 30 miles per hour. You want to make a U-turn. You come to a red light. You got to stop. And then you got to turn around. Does that make sense? So when you come to a stop, okay, what happens? Your velocity is 0. So and then you got to change directions. So that's what we have to do. So we're going to take the velocity, we're going to set it equal to 0, and we're going to see where it changes direction. And that's what we're doing. So we're going to take v of t, okay, this guy right here, set it equal to 0. And you're going to have to just use your calculator for that. Either graph it, see where it crosses the x-axis, and you should get t is equal to 0.536, and I'll just truncate it there. And the other one, you're going to get, or you should get 3.3117 or 18, either way. I just truncated it there. So these two. So that's where the velocity is equal to 0. Okay, so what do you do now? Well, you got to figure out what happens. Okay, so you're driving. So at t sub 1, you change directions. At t sub 2, at t sub 1, it's at 0. At t sub 2, it's also at 0. Okay, so remember, this guy is 0.536. And this guy is 3.317. You're going to plug it into your velocity. So you got to figure out here, what value is it? Is it positive or is it negative? Well, where do you plug it in? You plug it into your v of t. Okay, you're going to plug it into this guy right here. Okay, now just be careful. So, and if you do that correctly, you should get a negative here and then a positive. And then after, pick a value after 3.37 and you should get a negative. Okay, so down, up. So what happens is you're going to the left, okay, because velocity is directional, remember. You stop, go to the right, stop, go to the left, okay. And so what happens? You're changing directions here. All right. So what happens is you change directions here and here. Now, how do you say that on the exam? You would just draw this out. Some of you are very visual, and it's a lot easier for you to draw it out instead of write it out. And that's perfectly fine. As long as you can demonstrate to the grade, remember, they're human beings. Okay, they want to give you the points. They want to see. So if you just show this, okay, and you just say the particle changes direction, all right, and you draw this, and you'll be fine. Okay, the particle changes direction at t equals 0.536 and t equals this, you're fine. Okay, but as long as you have to show, okay, you have to show where it changes direction from positive to negative, and so forth. All right, and if you do that, that's 3 points. All right, part D. Let's go ahead and do that one. It says, is the speed of the particle increasing or decreasing? You see that word again? Okay, increasing and decreasing. And this is something unique to particle motion that you have to understand. Okay, when speed is increasing or decreasing, okay, and this comes up a lot. You know, it's just fundamental to these particle motion problems. Okay, when something is increasing, okay, velocity and acceleration have the same sign, okay? Same sign or direction, okay? So if velocity and acceleration have the same sign, you know it's the speed is increasing. Increasing speed, okay? If velocity and acceleration have the opposite sign, okay, the speed is decreasing. All right, it's slowing down. All right, so that's just fundamental, and I'm pretty sure your professors, your teachers have gone over that. So just make sure you have it with you where you can see it in your notes if this question comes up. Is the speed of the particle increasing or decreasing at t equals 4? So as soon as I see the speed and they're asking me if it's increasing or decreasing, I need to look at velocity and acceleration. So I need to look at velocity at 4 and I need to look at the acceleration at 4. So what's the velocity at 4? That's easy. Just plug it in right here and get your value. And if you do it correctly, you should get negative 11.475, and I'll just truncate it there. Now what about the acceleration? Well, I have to take the derivative of v of t, okay? So I have to do v prime of 4, okay? So the acceleration is the same thing as v prime of 4, all right? And if you do that correctly, you're going to get negative 22.29, I'll round it, 96. Okay, they're both negative, okay? So how do you answer the question? The speed of the particle is what? Increasing at t equals 4. Why? Because both velocity and acceleration, okay, have the same sign. All right, I'll say that again. Notice what I'm using. The speed of the particle is increasing at t equals 4 because both velocity and acceleration have the same sign. And that's important, guys, and you'll see that question come up over and over again. So when you have the same sign for particle motion, well, how do you know it's particle motion? Well, they're going to give you velocity, acceleration, positioning, and you'll notice, you'll see that, okay? So let's go ahead and do another one. This is, oh, actually this one was from 2013. So, and when I'm done with these guys, I want you guys to go over them again, because when I explain, say, oh yeah, I get it. But then you go over in your own and you're like, oh man, I forgot, what does this mean? Because remember, the goal of these is to understand. Okay, not just to do, but to understand what the problem is telling you. Because if you understand what it's asking, what's going on, boom, you'll be set. Because as soon as that clock says go, you know, you're nervous, emotions rambling. Okay, where's my this? Where's my that? Oh my, I can't do this. And so you get nervous. So it's really important for you to just dissect it, understand what you're doing, and you'll be fine. So let's do one more, 2015. And this one, you notice they actually give us a table with it too. But it is also part of a velocity. Okay, it says Joanna jogs along a straight path, and Joanna's velocity is given by the differential function v. Selected values of v of t, where t is measured in minutes, okay, and v of t is measured in meters per minute, given the table above. All right, cool. As soon as I see a table, I'm thinking, okay, Riemann sum, something like that. I got to do that. Or they're asking me for rate of change somehow. And remember, part A is always the easiest one. Use the table above to estimate the value of v prime of 16. Boom. Right here, where 16 is right here. So you're going to be using these four values, okay, to figure out v prime of 16. And remember, what's the derivative? The slope. What's the other way? Another word for slope? You know, from algebra 1, y2 minus y1. Okay, so I'll just write it out. So this would be, so 16 is between 12 and 20, so it'll be f of 20 minus f of 12, okay, over 20 minus 12. So these are the y values, okay? So what's the y value at 20? 240, okay? So it's 240 minus 200 all over 20 minus 12, okay? And if you do that correctly, on the top you should get 5. And then what are the units? Don't forget the units. Go, oh man, I don't know what the units are. Well, just look, what's 240? 240 are what? Meters per minute, okay? Meters per minute. So it's meters. On the top, it's meters per minute. What's on the bottom? Minutes. So it's meters per minute per minute. So you can write meters per minute squared. All right. And there it is, guys. Very simple. This question, 1 point right off the bat. Part 2, letter B. Using correct units, explain the meaning of the definite integral. You see the symbol again? Remember we talked about it in the other one, right? So explain what this means in the context of the problem. Approximate it using a right Riemann sum with 4 subintervals indicated in the table. All right. So let's go ahead and do let's do a Riemann sum. Set it up. So 4, right? 1, 2, 3, 4, and they want to use the right. So on the right corner, 1, 2, 3, 4. So when I do this, I should have four little expressions. Okay, so they want me to go ahead and set that up. Now, what happens when you integrate velocity? Remember we said when you integrate a rate, you get an amount. Okay, when you integrate a rate, you get an amount. Now, this is another fundamental question. Remember, the absolute value of velocity is what? Speed. So when you integrate a rate, you get an amount. Now you got to understand, remember velocity does this, right? Oh, I'm going to the right. Nope, change direction, going to the left. Oh, no, change direction again, change my mind. Oh, one more time. Right? So velocity just goes back and forth and back and forth. Well, speed, you got to add all these things to get the total distance. Right? That's why this is positive, then this is negative, then this is positive, then this is negative. Well, you have to go ahead and add everything to get the total distance. And so the absolute value of velocity is the total distance traveled, okay, between or the first 40 minutes. That's what it means. The total distance traveled, okay, the first 40 minutes. And sorry, I'm doing this kind of fast just for sake of time. And that's what it means. So the absolute value, okay, is speed, but this is going to give me total distance traveled the first 40 minutes. And that's what that means, okay? Now we have to use this in order to figure out or estimate, okay, what's her total distance, okay? So let's go ahead and do that. So the integral from 0 to 40 of the absolute value of Vt dt. So we're trying to find the total distance is approximately. So now remember, we've done Riemann sum before. All these are rectangles. Base times the height, perpendicular height. So from here, we're going to have 1, 2, 3, 4. Okay, remember, time is always independent. It's always your x because you can't control time. So from 0 to 12, what's that distance? 12 times what? Times the 200. All right? And then from 12 to 20, what is that? 8. And then what? Times 240. And then from 20 to 24, what is that? 4 times what? Boom, negative 220. Okay? And then 24 to 40, how much is that? Is that 16 times what? 150. Okay? So let's go ahead and do that. All right? So the first one is 12 times what? 200. Boom. Plus from 12 to 20 is you're adding 8 times what? 240. Plus, okay, from 20 to 24 is 4 times what? Negative 220. Plus what? From 24 to 40 is 16 times what? 150. Now, where does the absolute value come into place? Okay, now remember, V of t represents your y values. So you can do this. Remember, it's absolute value. That means our negatives are going to become positive. Okay? And we already know that because we know we have to add everything. Okay? Total distance is not going to be negative. If you get total distance, okay, how much did you travel? Oh, I traveled negative 56 meters. Well, that doesn't make any sense. Total distance is not going to be negative. It could be, velocity, but that's not the total distance traveled. Okay? You don't say how far is the park. Oh, it's negative 12 miles. You don't say that. So now here we can get all of this. All these are going to be positive except for this one, right? You see this one's going to become a positive. So I won't do the math, but if you go ahead and do all that correctly, you should get 7,600 meters. Okay? 7,600 meters. All right. And if you have a calculator, you can set this all up and put 7,600 if you want. Because as soon as they see this, they understand, okay, you know what you're talking about. You give this answer. Boom. If you want to be more detailed, go for it. Okay. And that's part A. That's part B. Part C. Okay. So in the first 40 what are we talking about? Minutes. In the first 40 minutes, she has traveled 7,600 meters. Okay. All right, approximately. In part C, Bob is riding his bicycle along the path. For the first 10 minutes, his velocity is modeled by this cubic measured in minutes, and B of t is measured in meters per minute. Okay. Find Bob's what? Acceleration. Look at that. At t equals 5. What do they give me? His what? Okay, B of t, Bob's velocity. You see that? Bob's velocity is given by this. So what do they want? They want his what? Acceleration. So what am I going to do? I'm going to find the derivative at t equals 5. Now, sometimes these questions, I looked at this like, wait a minute, that's too easy. But sometimes they're just that, just too easy. Like problem letter B, that one's worth 3 points. This guy is only worth 1 point. So all you do is take the derivative. Okay, now this is a good example of what you can see because you guys should be able to take the derivative of this guy. Okay, and this one is no calculator, which makes sense. okay? And so actually for letter B, you would have to do it by hand, okay? And just be careful. So for this one, you would just do the derivative, so that would be 3t squared minus 12 times t, okay, and that's it. And if you notice, it's not a very big, complicated derivative because they're just testing your ability for the calculus, not really all this algebraic stuff. So b prime of 5, so that gives you 25 times 3 is 75. 75 minus 60, okay, and that would give you 15. And if you notice, one of the things that you should do is when you're working on these problems, per minute squared, talk it out, talk yourself, do like self-talk out loud, because too many times you do it in your head and you're trying to beat the clock and trying to be on time, and you mess yourself up. But if you just kind of whisper to yourself, okay, I gotta take the derivative, I gotta do this, it'll control those errors. Okay, letter D, based on the model B from part C, find Bob's what? Average velocity. You see that word that come up again? That comes up a lot. Okay, the mean value theorem. The average velocity during what? The first 10 minutes. Okay, the average value theorem, 1, okay, b minus a over the integral from a to b of the function f of x dx. Well, the average velocity from 0 to 10, they already tell me from 0 to 10, so it's going to be 10 minus 0 from 0 to 10 of what? Bob's velocity. Okay, so we're going to integrate b of t dt. Okay, and so I have to integrate that. Now remember, this is no calculator, so we're going to go 1 over 10, the integral from 0 to 10 of t cubed minus 6t squared plus 300 dt. Alright, remember I have to integrate, so you're going to have to add 1, divide by 4, you add 1, becomes a 3, divide by 3, and then the 300 becomes a t. Alright, let's leave the 1/10 outside, and we're going to go from 0 to 10. Okay, and I ran out of room, but from here is just algebraic, and you should be able to do it. I believe you guys can do it, and so you should be able to get 350 meters per minute. Okay, so I like this problem because it gives you practice where you can't use a calculator, you have to do the math by hand, but it's very doable. And if you just guys understand what they're asking you, now I guarantee you, okay, if you get a FRQ this year on particle motion, you will get this: speed, total distance. They will ask you, okay, something like this with average, and they will ask you something having to do with the max or the min. But don't worry, we'll go over those, and I'll try to do as many problems as I can to help you guys out the best that I can. Alright guys, I'll see you guys next time.